Okay, let's do this this example of the mixing of two different phases of water. So what we're told is we have a sample, a 0.01 kilogram sample of 20 degrees Celsius water, and we'll use the abbreviation, we'll just call it water. When I use water throughout this problem, we're going to assume I'm talking about liquid water. And ice will refer to ice. So we have ice, which is ice, water, which is liquid water. And we have 1.2 kilograms of ice at minus 15 degrees Celsius. And we're asked to calculate the final temperature once these things mix together. Okay, so let's first figure out, is our final sample going to be ice or is it going to be water? Well, we can probably guess it's going to be ice because we have 1.2 kilograms of ice and only 0.01 kilograms of water. So we have 120 times more ice than water. So we can reasonably assume that we're probably going to have ice. But let's go ahead and show that in fact we do end up with water in the end. Or ice in the end of this problem. So what we're going to calculate first here is the heat released when our 20 degrees Celsius water, so heat released by the water, when our 20 degrees Celsius water warms to the freezing point, cools to the freezing point. Okay, well, heat is mc delta T, so we have 0.01 kilograms. The specific heat of water is 4190 joules per kilogram degrees Celsius. And when it cools to the freezing point, the change in temperature goes from 20 degrees Celsius to 0. Okay, so that's a temperature change of minus 20 degrees Celsius. You multiply those together and you get a heat that is 838, or negative, I should say, negative 838 joules. So that's how much heat is released when this water cools to 0 degrees Celsius. Now what about the ice? What is the heat added to the ice that has to be added to ice to have it warm from minus 15 to 0? Okay, well, we have 1.2 kilograms. The specific heat of ice is 2090. And it goes through a temperature change. It warms 15 degrees. So that number is 37,600 joules. Okay, so since the cooling of the water only releases 838 joules, but we would need 37,000 to warm our ice, since we would need way more heat to warm the ice, therefore our final sample is going to be ice. Okay, and it's going to be ice, and we're going to say it's at some final temperature TF. Okay.